Hello everyone, welcome to another video of the AP Calculus review videos. Today we will be looking at polar coordinates. So what are polar coordinates? Basically, like the Cartesian coordinate system, it's just another way to indicate position by using distance from the origin and directions to specify a location or a point. For example, in this example, we say that this is the polar axis, and this is the origin. And if I have a random point, an arbitrary point P, then it will be at a distance of r away from the axis. And then from the origin, we rotate an angle of theta to go to that point, which is the direction. So this will be the polar coordinate systems in a nutshell. And we can actually convert these points. So if you have a something polar, if the x coordinate is just r times cosine theta, because that's a trig identity, and y is equal to r sine theta. Or we can use Pythagoras, and r squared is equal to x squared plus y squared, and tan theta is y over x, given that x is not equal to 0. But usually we'll just be doing the calculations in the polar coordinate system, so we do not have to perform such tedious ways of differentiate. And now let's just look at the derivatives of such coordinates. So similarly to the parametric functions, we can just take the use chain rule to take the derivative. Let's just say that to find the slope of a polar curve, r is equal to f of theta, or we can just write it as f. Then dy over dx will be dy over d theta over dx over d theta, and then y is equal to r sine theta, or just f sine theta, and then x is r cosine theta, which is f of this cosine this. So if we want to find their first derivative, dy over d theta is equal to, we can just use product rule. So f of theta times sine theta plus f of this cosine. Dx over dt is f prime of this cosine plus f of this, and this is negative. It's actually negative, so let's just change this to a negative sign. And then we can't simplify it further, so the first derivative of a polar coordinate will just be f prime plus f cosine f of cosine minus sine. So this is the formula of the first derivative of polar coordinates. Now let's talk about integrating polar coordinates. And unlike the Cartesian ones, where it looks like adding little rectangles, we will consider our polar coordinates to be adding little triangles together. So this is an arbitrary triangle. This is theta. Then this is delta theta. And if this is r, then this length will just be like r d theta. So for each small triangle, the area is 1/2 base times height. Base is just d theta, and height is just r. Because these triangles are small enough, we can just consider them to be perpendicular to each other. So now how do we find the area? Well, we just need to add up all of these small triangles. So area is just the infinite sum of all of these triangles. which can be expressed as from alpha to beta, which are the initial. Let's say if we are trying to find the area of this region, then this one will be the initial angle and this will be the final angle beta. So 1 over 2 r squared d theta will be the area. Now let's start problem solving to try to understand polar coordinates. First, let's find the point of intersection of the graph of this equation. Let's say that r1 is equal to 1 plus cosine theta and r2 is equal to 3 cosine theta. So if these graphs intersect, then they should have the same length. So r1 is equal to r2. 1 plus cosine theta is equal to 3 cosine theta. 1 is equal to 2 cosine theta, and cosine theta is equal to 1 over 2. Okay, so now we try to determine what are the values of theta where cosine of theta is equal to 1 over 2. And then we find the values pi over 2 and pi over 3. So we just plug these values back into the original expression. And then we find out that there are these two points of intersection. Next, we should also check if the origin is the intersection. And how do we check it? Well, we just ensure like both curves have r is equal to 0, because if r is equal to 0, it passes through the origin. So if r1 is equal to 1 plus cosine theta, let's find if theta is equal to pi, it indeed happens. And then also for r2 is equal to 3 cosine theta is equal to 0, we find that when theta is equal to pi over 2, it indeed is 0. Therefore, the intersections are these two values as well as 0, 0. Let's move on to another question. We want to find the area that is enclosed by this region in this interval. So if r cosine 1 over 2 theta is equal to 1, then we can express 1 as secant 1 over 2 theta. So we just use the previous formula. A is equal to alpha beta 1 over 2 r squared d, which is equal to 0 to pi over 2 1 over 2 secant squared 1 over 2 theta d theta, and then we can integrate it ourselves or just use a graphing calculator. So cosine 0.2x. What do we find? We find that the answer is 1. Now let's find what integral represents one leaf of the polar rows r is equal to 3 cosine 2 theta. So these rows often just look like something like this, where there are different petals. So we just need to find the intersection, which is when r is equal to 0. So r is equal to 0 means that cosine is equal to 0. So 2 theta is equal to pi over 2. As well as negative pi over 2. So theta is equal to pi over 4. So these are just two arbitrary values we picked where the area inside, where the r is equal to 0, meaning that it's like at the origin. So in case it's one leaf. So the area is just alpha to beta 1 over 2 r squared d theta, which is negative pi over 4 to pi over 4, 1 over 2, 9 cosine squared 2 theta. d theta. And we find out because these type of curves are symmetric, it's also equal to 0 to pi over 4 9 cosine squared 2 theta d theta. And we find out this is equal to c. So okay, everyone, let's now do a free response question to practice our polar integration skills. Now let's read the question together. There's a graph of a polar curve. R is equal to 1 minus 2 cosine theta for this range. And let S be the shaded region in the third quadrant, bounded by the curve and the x-axis. So this is S. Now we should first write the integral expression for the area of S. So previously we have talked about the formula for polar integration, which is just between two angles, 1 over 2 r squared d theta. And then now let's just first find the bounds. We find that alpha is 0 because literally the curve starts here, so the angle is 0. Now we want to try to find the second angle. So we observe that at this point, r is equal to 0 because the curve is at the origin. So we just set the expression to be equal to 0 and then solve for the angle. One common misconception is that the curve does not necessarily start at the origin. It does not start at the origin, which is a common mistake, because if you plug this number into your calculator, 1 minus 2 cosine of 0, it's negative 1, not 0. So it starts over here. The curve starts here, but the origin is here. So instead, so this is quite important for finding the bounds. So we have to set this equal to 0, not 1, because if you were to wrongly think that the origin is here, you would see that r is equal to 1, but it's actually wrong. Okay, so enough of this talk. After we found the bounds, we just put this in the polar formula, the integrand 0 to pi over 3, 1 over 2, and then r squared d theta. So this is the integral expression of the area. Okay, so that was question A. Let's try to solve question B. We are trying to find dx d theta and dy d theta in terms of theta. So we can first write x as r cosine theta and then expand this expression. And then we will just take the derivative. This one is just trig identities. This one is power rule. You bring down the power and then it becomes to the power of 1. But then you need to chain rule it because, well, cosine is still a function. So obtain this one. And then y is equal to r sine theta, which is equal to this. And we can just use this trig identity. This is equal to sine 2 theta, but instead, so we don't have to use product rule, so our lives are a bit easier. After we differentiate it, we get this. Now, that was question B, and now to the last sub-question. Great. Let's try to find the equation in terms of x of y for the tangent. Okay. So in B, we have obtained dx d theta and dy d theta, and recall in the start of the video, we have said this is how we find the first derivative. So we can just put this on top of this one, and notice that we have simplified this using the trig identity. Sine 2 theta is equal to 2 sine theta cosine theta, which is over here. And then we just plug in the number that theta is equal to pi over 2, and then we obtain this. Now, great, we have the slope. So we can just find the x and the y by substituting them into these expressions 0 and 1. And this is just a slope-intercept form. So we try to solve for the equation, and then we find out the tangent line is just equal to y is equal to negative 2x plus 1.